everyone. I am again in front of you with the lecture of class 12th. In the lecture of class 12th, today I will solve the miscellaneous exercise of chapter 1. The miscellaneous exercise include all the topic, all the typical questions in that exercise. Okay, so I will start from the first question. The first question is fx is given to you, which is defined on r to r, real number to real number, and you have to find the another function, that is g, by using this, which is given to you. Okay, so let's start with the given terms which are given to us. How you can solve the value of g, that is gov is equals to fog is equals to ir. It is given to you. You have to find the identity element with these two elements. So let us suppose I will take the element x with fog and gov, that will equals to x. For finding the value of g, I will take these two terms. Okay, so by using these two terms, we can easily find the value of another function, that is g. Fog of x, that is equals to x. Okay, it will equals to f of gx, like this. Okay, put the value of gx in place of x in the given function. In place of x, we will replace x by gx, like this. Now, the next steps are very easy. We can easily find gx by taking this 7 on the right hand side. Gx is equals to x minus 7 and gx is equals to x minus 7 by 10. So this is the function which we have to find out. So this is very easy way to solve the function. Now come to the second question. What is the second question? Second question is also very easy. How to find, how to solve? That is totally based on the injective and surjective functions. Okay. So let's start with that question. That is very easy. How to solve? I will write the statement first of all, so that it becomes easy for you to understand. Okay, so let's start with the statement. Statement is let f from, this is the second question, let f from w to w, whole number to whole numbers, be defined by f of n. F of n having two values. One is n minus 1, second one is n plus 1. N minus 1 is if n is odd. Okay. And n plus 1 if n is even. It means we have two values for even and odd functions. We have to show that f is invertible, and find the value of inverse of f. So this is very easy question. To show the function is invertible, for showing this function is invertible, we have to focus on 1, that means injective, and on 2, that is surjective function. Okay, if I prove the function is injective as well as surjective, that means it is invertible. By using that invertible function, we can find the inverse. Okay, so let's start with the function's injectivity. First of all, we will prove it as for injectivity. We will work for injectivity. Okay, in injectivity, I have 4 cases. Case first. If n is n and if n and m belongs to even numbers. Okay, that is from even numbers. I will take the n and m. That means if I will start from f n equals to f m, that will equals to, if it is even, then n plus 1 equals to m plus 1. This 1 and 1 will cancel. That means n equals to m. It means f is 1, 1. Okay, this is 1 function. Now case 2. When I talk about case 2, what is the case 2? If n and m both belongs to odd numbers. If both belongs to odd number, I will start the mapping fn equals to fm. That will equals to, if n is odd, n minus 1 equals to m minus 1. This 1 and 1 will cancel. So we have n equals to m. That is f is 1 1 again. Okay, now come to the third case. Case third. What is the third case? If n belongs to even number and m belongs to odd numbers. Okay, you all know even and odd, two different numbers are there. Their mapping should be different. Okay, so we have, this implies n not equals to m. Okay, if n is even, if we add 1 here and we subtract 1 here, both are not equal. That means this implies f of n not equals to f of m. If I have two different numbers, then mapping is also different. That means f is 1 1. Okay, now come to the question number 4. Case number 4. Case number 4 is case 4. I will take n belongs to odd and m belongs to even numbers. So what is happening? That is, if n equals to not equals to m, because both are different. N is odd. That means if I subtract 1 and add 1, the both are different numbers. Both are not equal. That means f of n not equals to f of m. That is, f is 1 1. So this is 1 1 for 4 cases. That means ultimately fx is 1 1 function. Okay, now come to the onto function. Onto, that is surjectivity. Now we work at surjectivity. How we can work on surjectivity? That is very easy. Surjectivity. Very simple question. For surjectivity, I want to see for even and odd, for both function, it is applicable or not. For surjectivity, this is surjectivity. I will work at the surjectivity. Surjectivity means onto. How we can solve for surjectivity? First, if n is even. Okay, if n is even, there exists n minus 1 belongs to, n minus 1 is odd number. If n is even, n minus 1 is odd. So I will take odd number. N minus 1 is odd. That means when odd is number is there, this is even. We will work it for, okay, I will take not it is for n is even. I will take it for n plus 1. Okay, n plus 1 is odd. I will take the value n plus 1 is odd because extra 1 is odd number. I will put the value for even n plus 1 minus 1. I will put the value here when n is odd. Okay, this is odd. This and this will cancel. We get n. Okay, second case, if n is odd function, there exists, if n is odd, n minus 1 is even. So we have to work for n minus 1, that is for even number. N plus that n is 1, then n plus 1 is, this is n plus 1, not n plus 1. Okay, I will do, first of all, n is even, and if n is even, then one more number is odd, one more number is odd. That means I will put the value of f n plus 1 in this value. N plus 1 minus 1. Both are cancelled. We get n. Okay. If n is odd, we suppose n is odd, then one subtraction is even. N minus 1, I will put the value here. That is n minus 1 plus 1. Both are cancelled. We will get n. In both cases, if there is a value function n which belongs to the whole number, the n which we suppose from the whole number, their pre-images find out with the pre-images is also present in the form of even and odd. Okay, for even and odd there are two functions. We have to prove n plus 1 for the even and for the odd there is n minus 1. That means if I talk about f of If I talk about f of 1, that is the odd function 1 minus 1, that is 0. There means this implies for every element of W, every element of W has pre-image in W. Okay, that means this implies f is onto, that means f is invertible, because f is 1 1 and onto. I will repeat again this step. I have to suppose n belongs to whole numbers. I will take n is even. If n is even, the n plus 1 is odd. So we have to put in the even, that is odd numbers. Odd number is here. I will put the value of odd here, n plus 1. That is n plus 1 minus 1, both are cancel n. Okay, if n is odd, then one number negative is even. So n minus 1 is even. So I will take the value of even numbers, that is n minus 1. This will cancel, we get n. F of 1 equals to 0. That means if n1 is odd, so all these values, even, odd, 1, both, all have pre-images in W, that f is 1 1. This means f is invertible function. Invertible. For finding the value of invertible, for finding the value of inverse, what we have to do? If n is even, so we have, if n is even, we have f of n plus 1 equals to n. This is n plus 1 equals to n. That means f inverse n equals to n plus 1. Right? If n is odd, what is happening? If n is odd, the fn minus 1 equals to n. That means f inverse n equals to n minus 1. That means their two inverse is equals to, the inverse is equals to, their inverse are very simple. I will take this inverse from the injective function. Their inverse is equals to f inverse n. What is the value of f inverse n? There are two values of f inverse n. If n plus 1, if n is even. N plus 1 if n is even. Okay, and n minus 1 if n is odd. That means it have the same value. It have the same value which is given to us, same matched with the given function. This implies f inverse is equals to f. The inverse of function is function itself. So this is the way. The inverse which we get, I will get this inverse by using the onto function. This is the same algorithm to find the inverse of the given function. Now come to the third question. What is the third question? Third question is also very easy. How to solve? Very easy to solve that question. For doing that question, what is happening? I will take the values. I will explain one thing of the class 9th to you. The first of all, write the question. Third question is, if f from R to R is defined by f of x, that is equals to x square minus 3x plus 2. Find for function f of fx. Okay, so how we can find the for function? That is very easy. Before starting the question, I will tell you one formula which you all have done in class 9. What is that formula? A plus b plus c whole square. Are you remember that formula? That is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. What is the use of this formula and why I have told you about this formula? Let's start with the question and see, is it helpful or not? So I will start the solution with f of fx. That means in place of x, we have to substitute fx. Fx whole square minus 3fx then plus 2. Now I will substitute the value here. fx has a value x square minus 3x plus 2 whole square. Minus 3 and x square minus 3x plus 2 plus 2. I will only substitute the value. Now I will apply this formula in this place. Okay, what is that formula? Formula is a square plus b square plus c square plus 2ab, that is x square minus 3x plus 2bc, 2 into minus 3x into 2 plus 2ca, that is 2 into 2 into x square. Okay, minus 3, I will multiply 3 with each element x square plus 3 3s are 9x plus minus 3 2s are 6 plus 2. Okay, so how we can solve? X raised to power 4, 3 3s are 9x square, 2 2s are 4 plus minus 6x cube, x and x square, that is x cube, minus x square into x, then x into 2, 2 2s are 4, 3s are 12, minus 12x, 2 2s are 4x square. Okay, x square. Now come to the minus 3x square plus 9x minus 6 plus 2, that is minus 4. Okay, this plus 4 and minus 4 will cancel. I will take all the powers together. X raised to power has only one value. Now I will take cube has only one value, x6 x cube. Now I will take the square, 9x square, that is 9x square, then minus plus 4x square minus 3x square. Okay, now I take 12, that is minus 12x plus 9x, all the terms 1 2 3 4 5 6 7, 1 2 3 4 5 6 7, all the terms are there. We have x raised to power 4 minus 6x cube, 9 and 4, this is 1, that is 10x square, then minus 3x. So this is the way to solve the question of FOF. So this is the way to doing the question. Now come to the next question. How to solve the next question? This is very easy. Now come to the fourth question. That is also very easy. How to solve? I will start by using the statement which is given to you. That is very simple question. How you can solve? Write the statement first of all. Show that the function. Fourth question is given to you. Fourth question, that is if show that f from R to x belongs to R and x lies between minus 1 to 1 defined by fx, that is equals to x upon 1 plus mod x, where x belongs to real number is 1 1 and onto function, up 1 1 and onto function, up, this is 1 1 and onto function. You have to show that this is 1 and onto function. This is very easy question, but one thing you have to keep in your mind, that is it is of modulus function. So we have to solve it by two cases. In the first cases you have to take x greater than equals to 0, and in the second cases you have to take x less than 0. Okay, the procedure of doing the question is same as other questions, but you have to take the two cases in this because of this absolute value, that is modulus. Okay, so come to the question how to solve. Solution. First of all, case 1, if x is greater than equals to 0. Okay, so first of all, then fx is equals to x upon 1 plus x. I will take x upon 1 plus x. For injectivity 1 1, for 1 1 let x1 and x2 belongs to R. We will take two numbers. That means fx1 equals to fx2. I will take this value, place x1 and x1 here, x1 upon 1 plus x1. If x1 is there, the both values will be changed by x1, and this is also 1 x2. Okay, now I will take the cross multiplication x1 1 plus x2, that is x2 1 plus x1, right? I will multiply here x1 plus x1 x2 is equals to x2 plus x1 x2. This and this will cancel. Okay, the answer, the value which we will get, that is x1 of x2. That means f is 1 1, right? This f is 1 1. Okay, now come to the f is 1 1, and after that I will do the work on to function, that is surjectivity for on to. I will take the values according to this. The function is given as x upon, that is x upon 1 plus x. That means this x is greater than, that is x. I will suppose x y belongs to, because of this is, I will take the value 0 to, if I take it as -1, so I will take the value -1 to 0. Okay, I will take, not taken that value 0 to 1, that is I will take the value of 0 and 1 according to the values. This is -1, fx should be less than 1. Okay, so I will take the value from 1 to 0 to 1 like this. Okay, I will suppose the value, because it should not be infinity, it should be fx greater than equals to 0, greater than, that is less than 0, less than 0, it should be less than 0. Okay, so I will suppose the value out of these three limit, I will take 0 to 1, the function of modulus, the half portion, that is from y. So fx is equals to y. Okay, that both will values, I will equate these both values, x upon 1 plus x is equals to y. Now my next step is to convert x in the form of y. That will equals to x is equals to y 1 plus x. Okay, now multiply, because I want y plus yx. I want the value of x in the form of y. So I will take this y on the left hand side like this, x minus y, x is equals to y. Okay, the value is x taken 1 minus y is equals to y, and x is equals to y upon 1 minus y. The value may be equals to 0 but never be equals to 1. That's why I have to take this y from 0 to 1. Okay, it totally depends on this value. Y should be greater than, it may be equals to 0 but greater than 1. It may be equals to 0 but not equals to 1. That means the interval is given only -1 to 1. So I have to take the values this. So this implies f of 1 y upon 1 minus y is equals to y. That means if I suppose a number, their pre-image is also present in the form of y. That means f is on to from this to this, 0 to 1, not open, to 0 to 1. Okay, I will not take equality sign with 1 because it become infinity. Okay, now I will take in the case 2. Case 2, I will take the case 2 and doing the method of doing same, doing question, the way of doing that question is same as this question. So I will start the case 2. That is also very simple. In this way we can easily prove it is 1 1 and on 2. Okay, to come to the questions, second part. What is second part? That is equals to case 2, x less than 0. When x less than 0, fx is equals to x upon 1 minus x. Got it? Now I will do the question in the same manner. Okay, first 1 1. Let suppose x1 and x2 both belongs to set of R. That is the first real set of all real numbers. F of x1 equals to f of x2. Okay, put the value here x1 upon 1 minus x1 equals to x2 upon 1 minus x2. Take the cross multiplication 1 minus x2 equals to x2 1 minus x1. Okay, so this is the way. Now multiply x1 minus x1 x2. Our target is to show x1 equals to x2. Okay, so x2 minus x1 x2. I will cancel this and this, and we have x1 equals to x2, and f is 1 1. First, f is 1 1. We have to start from the same mapping and reach at x1 equals to x2. Okay, so this means the f is 1 1 in the second case also. Now come to the on to. I will take the numbers. Question fx is given as, that is x upon 1 minus x. I will take y belongs to minus 1 to 0 open interval. Okay, minus 1 to 0 because the y which we get, that should be greater than minus 1 to 0. It is divided into two parts, minus 1 to 0, 0 to 1. So I have to prove for 0 to 1. Now come to the minus 1 to 0. Fx is equals to y. Equate these two. When you equate these two, y is equals to x upon 1 minus x. Take the cross multiplication like this. Now the next step is y minus yx is equals to x. I will take this y on the right hand side to get the value of x in the form of y. Okay, so y is equals to x plus yx. I will take x common. That is y is equals to x 1 plus y. The x is equals to y upon 1 plus y. Now its value is greater than that. Not be equals to minus 1 and not be equals to 0. It should be positive. That means f of y upon 1 plus y is equals to y. This implies f is on to from minus 1 0 to minus 1 0. So its value varies from minus 1 to 0 to minus 1 to 0. This implies f is 1 1 and on to. We have to show that 1 1 and on to. In the both cases it is 1 1 and on to. Okay. Now come to the fifth question. Which is the fifth question? That is also very simple. Very simple question. In that question you have to only show the injectivity, that means 1 1 and on 2. So how we can show? That is a very simple method. How we can show the 1 1 and on 2? That is very simple. Fifth question. This is the fifth question. Fifth question is show that f from real number to real number given by fx is equals to x cube is injective. You have to prove it for injective. Injective means 1 1. Okay, so we have to work for only 1 1. Okay, so I will start the solution. Let x1 and x2 both belongs to real numbers. That means if I will start from x1 is equals to x2, x1 cube equals to x2 cube. I will take this on the left hand side, x1 cube minus x2 cube is equals to 0. I have the formula in class 9th, a cube minus b cube. What is that formula? A minus b, a square plus ab plus b square. This is the formula of class 9th. I will write this formula x1 minus x2, and in this place we have x1 square plus ab, x1 x2 plus b square, x2 square is equals to 0. Okay, now this will never be equals to 0 because it will fall real numbers. If you include, there are two different numbers or two same. If you want to same numbers, so these are x1 and x2 equals to 0. It will equals to not equals to 0. x1 equals to x2. This implies f is 1 1. This is only 0 in that case when x1 and x2 both are 0 0. Otherwise it will never be equals to the 0 number. It may be equals to the 0. From here we can get the value f is 1 1. Okay, the conclusion of these 5 questions means you have to prove the functions for invertible function is, the condition for invertible function is 1 1 and on to. Okay, if for finding the 1 1 function you have to take the same mapping and reach at the same numbers. If you will start from the different mapping, the number should be different. Okay, this is the method of doing the question of 1 1. And on to, for on to you have to take that y that belongs to the numbers that related to the second set, and for y you have to change the x into the form of y, and from there we will get the pre-image. By using pre-image we can show that it is on to. Do the practice of these type of questions. Thank you.